insect killer. So they were using it as a pesticide for killing mosquitoes, and they were making it in the laboratory, and one of the laboratory guys set his cigarette down on the counter, got some DDT or one of the chemical very much like it in the lab, picked up the cigarette, put it in his mouth, and thought, wow, that's really sweet. And so as they were designing and making these different compounds to kill insects, they found out that these compounds were very sweet. The insects were attracted to them. They killed insects really well, but they also worked really good as a sweetener. In fact, they're many hundreds to thousands of times sweeter than sugar, so you could use a very small amount of it and put it in your stuff, and it would substitute for sugar. Our body can't break it down, but it's definitely a chemical and definitely causes some problems. Now, obviously, they took DDT off the market because it was causing cancer and different problems, but they didn't take the artificial sweeteners off the market because they sell they make a lot of money. So, how does the damage start in our digestive system and in our body? Environmental toxins. Anybody seen a picture like this anywhere?
Mm-hmm.
Yeah. Food, specifically candy, and then pesticides and different kinds of products that we spray on our foods and herbicides and things to grow more food faster. So as we put all these chemicals on our body, just like the artificial sweeteners, they go in and they start to attach to different parts. You can't break things down. They can attach to our digestive system. They attach to the nervous system. They get absorbed into the bloodstream, and they start to cause damage. We also, in addition to breathing in this stuff and absorbing in these different toxins and chemicals, we start to take some of these magic pills, and they, for example, an antacid, there's lots of different ones on the market, reduce the acid in our body, which then when we don't have enough acid, our food doesn't break down the same way, so it leads to incomplete food breakdown, which then causes bacteria to try to break down that food. Some of the bacteria is good, some of it's not, which causes fermentation in the stomach, and then which leads to different types of food allergies. So we'll talk about this specific process and how that works, but medications do cause side effects because they're chemicals that are designed to alter how our body is functioning. Some of them are for reducing acid, other ones are for causing other types of reactions in our body, but one of the major side effects of different medications is it alters how our body breaks down and uses food. So as we build up these toxins, whether it's a medication or a pesticide or an artificial sweetener in our body or any kind of food that we're not supposed to be eating that we can't break down, our liver is our main organ that's for detoxifying. That becomes toxic and clogged. Our colon becomes damaged, and we start to develop some type of digestive pain or problem. The bottom line is too many toxins are in our body. We're accumulating more toxins than our body can eliminate these toxins or detoxify. So let's say we're drinking a can of beer and we're putting this toxin in our body, alcohol. If we're drinking it very slowly, we probably won't feel anything, but if we're drinking alcohol faster than what our body can metabolize it or break it down, faster than what the liver can get that alcohol out of our body, we start to feel an altered state of mind, or what some people call a buzz, or they feel differently. And so, same thing happens in the body. If the liver is not detoxifying other products that we're putting in our body fast enough, we're going to accumulate that. We can start to damage our brain or our digestive system. So, what happens as we start to damage the digestive system is we start to get, this is a picture of the colon, we start to get what's called a leaky gut. So if you look at your pictures here, there's going to be a picture of a brain, and then there's a picture of a gut. It might be the first page there on the handout. If our digestive system is working well, when we look at the lining of the gut, we have small openings in the gut. Very small openings, and so our body can determine what passes through these openings and gets into the bloodstream. As we start to damage the digestive system, what happens is this opening starts to go from closed to more wide open, which allows proteins to get into the digestive system. So if we have a protein that's big, that's bigger than what the hole should be, the protein is going to have to get broken down before it can get absorbed into the body. So proteins in and of themselves are good things, especially if they're broken down into an amino acid, which is a building block that we can use. But if we have a big protein that's not supposed to be in the blood system, that our body doesn't want to see there, and now we start to get damaged, and one of these proteins here moves through the lining of the digestive system and into the bloodstream, our body says, hey, that's not supposed to be there. What are you doing here? This is a foreign product. And now it's going to start to create an antibody to that protein. So an antibody, I have a little picture of a Pac-Man here, or a warplane. Antibodies are designed to see this protein and attack it and destroy it. So what's another example of a protein that's in our blood system that's causing a problem? That would be a virus. And so our body sees these virus proteins that aren't supposed to be there. We want our body to attack those proteins to break down, destroy the virus before the virus can multiply and cause us to get sick. But if we have, let's say, a wheat protein that's supposed to be broken down before it's absorbed into our body, and it doesn't get broken down, and the wheat protein, which is called gluten, moves into the blood system, our body sees this wheat protein, this gluten protein, and it attacks the wheat protein and breaks it down. So far we're not too bad. All our body's doing is it's attacking wheat protein, or dairy protein, or peanut protein, or cat protein, which would be an allergy to cats. Our body's attacking these proteins. The problem becomes when our antibodies start to recognize our other parts of our body as a protein. So an example would be, we have this wheat protein, which our body would see as like gluten, and let's say this protein is called ABC protein. And every time we eat this ABC protein, our body sees this ABC protein, and now it's going to attack it. Protein is moved into the bloodstream. The problem is, the lining of our joints may be DABC protein, and that's the lining of the joint. And so our body's moving through, these antibodies are moving through, and it recognizes part of our own body as this protein that we've just been eating, that it's identified as a problem, and now this antibody, this war cell, is going to attack our own body. So it will start to attack our colon, and if it attacks our colon, that would be called Crohn's disease. If it attacks our thyroid, it would be thyroid disease. If it attacks our pancreas, that would be diabetes. If it attacks our joints, that would be called rheumatoid arthritis. So there's a bunch of different types of autoimmune disease. The problem is when our body sees one of these protein chains and identifies that protein chain as one of these other foreign proteins that's floating through our body. So if we don't have the openings and the big proteins aren't getting in, we won't form the antibodies, the war cells, which then won't cause our body to recognize other parts as problems. So every time we eat, let's say it's dairy that we become sensitive to. Let's say the big dairy protein moves into the bloodstream, we attack the dairy protein. Every time we drink milk or eat cheese or any kind of dairy protein, and our body makes these antibodies, and all these antibodies are circulating around, every time that we do that, now we're going to start to attack different parts of our body. So let's say it's our colon that it recognizes as a problem, and we're eating dairy, and now we're attacking our colon every time we're eating dairy. If the problem is gluten or wheat, every time we're eating gluten, our body is making these antibodies, and it starts to attack our own body. It's going to attack our joints. It's going to attack our brain. And so we need to identify what the cause of the leaky gut is, what's causing damage to the digestive system. And so that's the environmental toxins, the artificial sweeteners, the artificial colors, the artificial preservatives, all the chemical stuff that's not supposed to be in our food. That is what damages the digestive tract initially. We remove the cause of the leaky gut, we eliminate those toxins out of there, the gut starts to heal, and so these junctions of these big openings, they start to close. Now the big proteins can't move into the blood system. We also want to identify the protein that